today we are going to learn how to factor by grouping. Factor by grouping works with polynomials that have four terms. So these are not trinomials, they are polynomials with four terms. So one, two, three, four. And the way this works is you want to see the polynomial as two terms and two terms. So we're going to sort of split like right there. Okay, so we've got the first two terms and we've got the second two terms. And you're going to look at the first two terms. I have x cubed plus 7x squared, and you want to see what is common to both of those terms. So you're finding the GCF of both of those terms. So there's no number that's common to both, but I do have an x that's common to both, and the smallest exponent is x squared. So you're going to factor out x squared. When you divide x cubed by x squared, you get x, and when you divide 7x squared by x squared, you get 7. So remember, if I were to redistribute this, I would get what I started with, okay? Then you're going to look at the second set. I have plus 2x plus 14, and I ask myself what is common to both of those. Well, there is a 2 common to both of those, so I'm going to undistribute. I'm going to factor out a 2. And 2x divided by 2 is x, and 14 divided by 2 is 7. And what happens when you factor by grouping, what should happen for this to work, is that you have a term that is common to this part and this part. We have a binomial that's common to this part and this part. So since this x plus 7 is common to both, I can now undistribute it. I can bring that x plus 7 to the outside, and it needs to be in parentheses. And on the first part, it leaves an x squared, and it also needs to be in parentheses. And on the second part, when I take x plus 7 out of this, I'm left with a 2. So I end up with x squared plus 2. That is also sort of undistributing, right? I could, and we don't normally do it this way, but I could distribute that x plus 7 to the x squared and the 2, and I would end up with this. Once you get to this point, you are done. You have factored this polynomial using grouping. The next one is x to the fourth plus 4x cubed plus 2x plus 8. Again, we're going to look at the first two terms and the last two terms separately. So with x to the fourth plus 4x cubed, there is no number that's common to both of those. X is common to both. You always want to use the lowest exponent, and I have x cubed. And when I undistribute an x cubed or factor it out, I'm left with x plus 4. Then I look at the second one, 2x plus 8. There's no variable common to both, but 2 does divide 2x and 8. So I'm going to factor out an 8. I'm going to undistribute it, and I end up with x. 2x divided by 2 is x, and 8 divided by 2 is 4. And what should happen every time is you should end up with something that's common to the first half and the second half. Since that x plus 4 is common to both, I'm going to factor out the x plus 4, make sure it's in parentheses, and then I'm left with x cubed from the first half and 2 from the second half. So I do end up with two binomials here, but notice that they look a little different than the binomials that we have been seeing when we factor trinomials. Next, I have x cubed plus 4x squared plus x plus 4. Again, look at the first two terms and the last two terms. X cubed plus 4x squared, I can factor out an x squared, and I'm left with x plus 4. Now, over here, I have x plus 4. There's nothing common to both of these. It might be helpful to say, well, this is just 1 times x plus 4. Okay, I can factor a 1 from both of those. Obviously, dividing something by 1 does not change it. So now I have x plus 4 common to the first half and the second half. So I'm going to factor out x plus 4. And in the first half, I'm left with x squared. In the second half, I'm left with plus 1. So this 4-term polynomial factored into x plus 4 times x squared plus 1. As usual, things get a little sticky when there are negatives involved. Okay, so this polynomial is 4r squared s minus 8rs minus 3r plus 6. And I want to look at the first two terms and the last two terms. Well, the first two terms, let's see, there's 4 that's common to both. There's an r common to both. Always use the lowest exponent, and s is common to both. When I factor out 4rs, I'm left with r in the first term minus 2 in the second term, right? 8rs divided by 4rs would be 2. Now, here's the kicker when you have a negative in the middle term. When the middle term is negative, whatever you factor out, you also want to factor out the negative. So I look at 3r and 6. The only thing they have in common is 3, but I'm going to factor out a negative 3. Okay, and what happens when you factor out a negative is it changes the signs. So when I divide negative 3r by negative 3, I end up with r. And when I divide 6 by negative 3, I end up with minus 2. So that changed the signs because I factored out a negative. Notice that if I redistributed here, negative 3 times r would be negative 3r. Negative 3 times negative 2 would be a positive 6. And that also gives me r minus 2 common to the first half and common to the second half. So I'm going to factor that r minus 2 out. Remember to put it in parentheses. When I factor it out of the first half, I'm left with 4rs. When I factor it out of the second half, I'm left with minus 3. So I end up with r minus 2 times 4rs minus 3. So let's look at another one that has a middle term that is negative. So here's my split, 3x cubed plus 15x squared, and then minus 2x minus 10. So in the first half, 3x cubed minus 15x squared, 3 is part of my GCF, and then x squared is part of my GCF. So when I factor that out, 3x cubed divided by 3x squared, I'm left with x, and 15x squared divided by 3x squared, I'm left with 5. Now, since this middle term is negative, that means I want to factor out a negative with whatever's next. So I look at minus 2x minus 10. The only thing that's common to both of those is a 2. So I'm going to factor out a negative 2, and that's going to leave me with a positive x, and then negative 10 divided by negative 2 is positive 5. I'll know I've done it correctly when I get a binomial, something in parentheses, that matches. So since the x plus 5 is common to the first half and the second half, I'm going to take it out. When I factor it out of the first half, I'm left with 3x squared. And when I factor it out of the second half, I'm left with minus 2. So that is how you factor using grouping.